Howdy folks, welcome to another amp repair. This is another Fender amp, and just going to get my printer thing out of the way here. Alright, so I'm going for a different camera angle here. I hope this works. Basically this is the Fender Quad Reverb, and what I've done so far is replace the master volume knob, because the one on there wasn't the original one, and the screw was all stripped out, so when you were turning it nothing was actually happening, and when you went to push pull it, it wouldn't actually grip onto anything. So now brand new knob, so it's you know, nice and working correctly. The good news is all the parts arrived that I needed to replace, so we're going to get started with the bias caps here. So this is the negative bias. We're going to replace those, and then we're going to go up here and replace the caps here, up here on the board, the main board. And they're originals. Some of them are leaking and they have black stuff all over it. We're just going to replace all that too. Also, what we're going to do is get some of these tools out of the way. Might keep that one handy because I'll need that. Don't need these. I've got 4 resistors here. You'll have to excuse the mess. I just finished some cabling work the other day and I didn't clean up after myself. We're going to also be replacing these resistors here. What are they? They are the 470 ohm resistors that go and fry themselves on top of the main valve sockets for the 6L6s. They are often situated right above the valve sockets, or the tube sockets, whatever you want to call them. And basically what happens is they cook. The other thing is that some of them have been replaced, some of them haven't. For the sake of, you know, like these are about, I think, 90 cents each. For the sake of $3 and whatever cents, you know, let's call it $4. Why would you not replace them? So we're going to do that. I also am going to replace the 1500 ohm, so 1.5 kilo ohm resistors that go in here too. So let's fire up the soldering iron and start to unsolder stuff. Alright, so soldering iron should be nice and hot now. First things first, what we're going to do is replace these 80 microfarad 75 volt caps that go in the negative bias circuit. We're going to replace those with these nice German-made F&T caps. Now the closest value I can get is 100 microfarad 100 ohm. With a valve amp you don't need to be super precise. Obviously, I don't want to change the values too much, but basically 100 microfarad, 100 volt is good. The voltage doesn't matter. Go higher, always go higher than what's in here. So the schematic and these caps both look the same. So these are originals, and I know after doing many of these, you always get these white filter caps in here. They are the standard ones, 80 microfarad, 75 volt. If you find 80 microfarad caps, make sure that the voltage, this is the most important part, the voltage is 75 volts or higher. Now, I tend to go higher, and the reason why is this. These amps and the transformers and everything was designed way back when our mains voltage was lower. It turns out that our main voltage these days is higher. And what that means is every volt that goes up, that goes into the transformer, gets transformed at the same ratio it gets transformed in with the lower voltage. What that means is if you've got, let's say for example, 70 volts coming out, minus 70 volts, but you know, let's call it 70 volts. If you go up 1 or 2 volts on the input of this transformer, the mains voltage, well, that 70 volts that's going into these is going to be higher, much higher, 75, maybe even 80. That's going to put a lot of strain on these caps. Now, they are manufactured with a little bit of a leeway. They have what's called a surge voltage. That's why old filter caps you find on older amps will have, instead of 75 volts or 100 volts, we'll say working volts. Okay, and that often means there's a little bit of leeway there. There's a peak voltage and a working voltage. Ultimately though, whichever way it works out, the reality is that going higher in voltage does not hurt. Going lower in voltage will make some sparks. So 100 volts is okay. Now the microfarads are more important. As close as you can get is best. 50 is a bit too low. I'd rather go a little bit higher. And this is a solid state preamp, a solid state, this is a solid state power section. You can see here the rectification solid state. It's not a tube rectifier. So the filtering and all this stuff is not as vital. It's still important, but not as vital. So going up to 100 is okay. So that's what we're going to do right now, is we're going to remove these two filter caps here. Now, I did drain these, but the amp has been sitting here waiting for the parts for a little while. So what I'm going to do is grab myself a little wire, like this one right here, and basically I'm going to drain the filter caps again anyway. So best way to do that is ground to chassis, okay, and then just don't grab the metal side of this, grab the insulated side, and I just sort of sit it against the positive terminals of any caps you see. Now these ones are okay, but what I tend to do is we got our rectified wire here that goes into this point, which then goes to the power switch, which then goes to the filter caps, the main filter caps in the dog box. We haven't replaced those yet. We'll get to that in the video in a second. And then basically I just sit here and I press these this resistor down while insulating myself, because I don't want to get electrocuted by any residual voltage. It doesn't even matter if it's 50 volts or 20 volts, or you want it to be 0 volts. Now, letting go of this, the caps are going to start recharging, and that's an unfortunate advantage of those caps. The disadvantage is that it can shock you again. The voltage is low enough to work on though. I'm not going to get any crazy sparks flying at me and scaring me half to death. Worst case scenario, ending up in hospital with heart palpitations, possibly worse. We want to avoid that completely. So, now, these filter caps, they are grounded, and they're grounded directly to the chassis. This soldering iron is a 60 watt soldering iron. I've got it set at about 375 degrees Celsius. Truth is, it's not going to be hot enough to melt the solder on these chassis points right here. I'm going to have to get the big bertha out to do that. But there is another way to do this, and it's called a J-hook, which I'm going to do in this amp here. It makes life easier for the next technician who works on it years later. Mechanical connection on both sides. We have the J-hook, okay? Filter cap is in place. Everything is nice and solid there, okay? Next, we're going to move on to, let's get some of these filter caps that we aren't going to use just yet out of the way. They're all hooked in together like a barrel of monkeys, which I think I have that game somewhere. Anyway, so that goes there, that goes there. Okay, now, these all look the same, but they might be different. So this is 25 microfarad, 25 volt. They go onto the plates, I believe, if I remember correctly, the plates of the 12AX7s or 7025s, whatever you want to call them. I think they're all 25 microfarad. I'll have to double check. I ordered them so long ago. Yep, they're all 25. Now let's just check the caps in here. 25, 25, 25, and 25. Okay. 1, 2, 3, 4. How many do I have? 1, 2, 3, 4, 5. I think they were a 5-pack when I got them. So anyway, the ones that are in the amp by standard are Mallory's. The ones I'm replacing them with are Sprague. They're both high quality, so that's what we're going to do. Okay. Now what I'm going to do is probably start on this one right here. and then I'll do the other ones that are just out of shot. So you'll just have to imagine that I've done the rest of them. Oh, another thing to point out, these filter caps here, they're all, they are also, they have polarity. So you got to make sure you're going the right way. And in this case, the right way is the positive side is at the back of the amp, the negative side is the front of the amp. And that's the same for all of these. Now, maybe I'll just change the angle here a little bit so you can actually see what I'm doing. So I'm going to replace this first one, and I'll show you a little trick here to help out with the length of the terminals you need on these caps. So what I'm going to do is replace this one here because it's in shot, and then it's basically rinse and repeat for all the other ones. So get your soldering iron on the terminal here, and I'm just getting that solder flowing, so that side's off. And I'll do the same on the negative side. The negative side again is on the side of the amp where your dials are, where your pots are. So just heat up that solder joint. I'm probably going to have to flow some more solder into this anyway. Caps in place. Sometimes it helps to flow some solder onto the joint that you're trying to undo. Come on. There we go. Get out. Because what can happen then is the new solder will help flow things better. Okay, now here's the trick I'm going to show you. I'm going to put the new cap and the old cap right next to each other, and I'm going to cut the terminals at exactly the same length. So, basically same length. I've given it an extra couple of millimeters on either side. I can always trim it down. You can't add it back. So, what I'm going to do now is essentially put the cap back in place, the new cap I should say, and the terminal should be the exact right length that I need. Okay, so again, I'm going to make sure that I orientate the rating of the cap so that it is easy to read. I've just bent the terminals over so that when that goes in, it lines up with the strip correctly. The turrets, they're not turrets, are they? What are they called? Eyelets? I guess they're eyelets. And let's just do a little, yep, that looks good. Okay, so we grab our tweezers, grab our soldering iron, and we're going to put this back in place, remembering the orientation. Okay, so let's heat up that joint again. Let's get in there. Let's get that solder flowing, and as soon as it does, we'll be able to shove that terminal back in. Unfortunately, sometimes they get stuck because these eyelets often have more than one component going into them. And there we go. Having more than one component going into them often makes it more challenging to shove in the other component. So let's grab the next component on this side and get this side happening. Okay, that's made a nice connection in there. Perfect. Now I'm going to go back and do this side because I feel like that terminal has not gone all the way in like it should, and I want to make sure that it is a good solid connection, because this amp in particular goes into a 4x12 cabinet. There's going to be a lot of vibrations. On top of that, it's going to be, well, you don't know where it's going to end up. So you want to make sure that everything is nice and solid and you're not going to have any issues. Don't want the amplifier to come back. Alright, so one of those is done. We got 3 more to go. So I'm going to do them off camera. You can't see that from this angle anyway. And then I'll turn the amp over and we'll do the dog box, and basically the amp will be just about ready to go. The final thing will be replacing these 470 ohm resistors down here, followed by the 1500 ohm resistors, and I'll show you what they look like. And then we'll power the amp up and check the bias and make sure everything works and is ready to go. So, stay tuned for more. Alright, just to give you a little bit of a tour of an update of what we've done so far. We've replaced the negative bias caps in here. We've got this 25 volt, 25 microfarad Sprague going up a little bit higher. We've got 1 more here and 2 more here. So 1, 2. They're black, so you can't see them too well against the black turret board here. The next thing I'm going to replace is coming down here to the 4 6L6s. Let's zoom in a little bit here and get focused. I'm going to replace these 2 resistors on each one of these tube sockets. Now you can see the resistors are all different. So, well, they're all the right value, but you know what? If one resistor was replaced for the sake of, you know, under $1 in parts, just replace the whole thing. So this is one of those brown resistors. It is the square end, so it's likely not drifted, but it's sitting right above a 6L6 tube, running hot, and all that heat is coming up this way towards us. And these things cook, right? They just cook. That's an original likely. This is not, but I'm going to replace both. And I'm going to do the same here. You can see in this tube socket, that's the same value, but it's a completely different resistor. That's the same as the one we just looked at. If we go up to the next one, completely different. Okay, that little tiny resistor there, that looks like a little half watt, maybe quarter watt, and then what this looks like a half watt, so that's probably a quarter watt. Completely different yet again. And then finally we get up here to this one. There's a tiny little resistor in there that's probably cooking. And then there's this one here as well. So the ones that are going across the tube socket are the 1.5 kilo ohm resistors or 1500 ohm resistors. And these are the 470 ohm resistors. We're going to replace all of these right now. Yummy. Old, delicious, mismatched, cooked resistors have now been replaced with nice, tidy resistors, not capacitors. Damn it, I did that before. So everything has got a mechanical connection now. Everything is nice and tight, not moving around. Well, you know, it's not going to be moving around as much as it did before. So now onto the dog box, the dog house, whatever you want to call it. And we're going to change the big capacitors. Now normally I do this first, but because the amp is already situated in this sort of orientation, I'm just going to go ahead and flip it over now and then do that bit last. Alright, so I've saved the best to last. This is what's under the dog box or the dog house. Capacitors flapping around like this, and they're not axial capacitors. Every terminal is down here on this end. There's all these wires everywhere. It's not very tidy. I mean, look at this stuff. It's horrible. So I'm going to have to reverse engineer it and put it back to standard using the correct capacitors. So whoever's done this, good for you. You win the award. Look at these wires. They're just stuffed. Okay? And they've like... yeah. I don't even want to talk about it. But I'm going to look at the values of these capacitors. So here's a 20 microfarad, 500 volt. Okay, and then here's the jumper wire for it. So we won't need this anymore. So that looks like it's the negative. Okay, so at least the polarity's right. That's negative. Obviously, you know, red with black. Why not all black? Who knows? Just to make life confusing. So there's going to be two capacitors here that are the 20 microfarad. Now what I have here as the replacements are the 22 microfarad. So these are going to go this way on this side, and you can already see they're much smaller. It's going to be tidier, and it's going to look original. And that's the most important part. We want this amp to be nice and original. So that's going to go there. Another one is going to go here on this side. So there's going to be a positive terminal here and a positive terminal here. And then we have this negative flapping around, and there's going to be negative on this side too. And we'll double check that by putting the multimeter on this terminal here and connecting it to ground just to see what happens. Because at this stage, when you get wiring like this, be suspicious. Be very suspicious. Which I am. Very, very suspicious. So, first thing's there. Now the second thing, here's a 10 microfarad 500 volt. This one here, this little one. A Richie. Got Richie Golds. Richie Rich. And what they've done is, you've got your let me get rid of this cap in my hand. You've got the positive coming into positive, and what they've done is connect it up to the other positive. Okay. So in series? No, parallel. Which, when you parallel this, you're getting, I think, 5 microfarads, 1,000 volts, instead of 10 microfarad, 500 and 500. So basically, I mean, this should be another 20, because my understanding is it's 3 20 microfarad caps. So 3 of these ones, 22s, yep. And then 2 of these ones, which are 100 microfarad. I think the book calls for 75. But those ones are actually put in series up here. And those ones, because we have positive on this side, negative on this side, and a jumper, that's going to be 50 microfarad, 1,000 volts. Oh no, in this case, hang on, 50 microfarad, 900 volts. Okay, right now that's sitting on 50 microfarad, 1,000 volts. Yes, we're going lower in voltage, but that doesn't matter because these are the wrong caps anyway. It's not to spec. Not to spec at all. This thing is definitely not to spec. It's actually, it's just a shambles. What a mess. Look at this. Look, it's just floating around, man. I know it's been glued down, but you know what? This just popped off. It was glued down, but it wasn't actually attached. Like, nasty. Nasty work. Whoever did this, and they've put, what, nail polish on the terminals? What the hell's that going to do? Yeah, I really care about my work. I'm going to put nail polish on the terminals. But look at the mess you've made, you joke. Whoever did this is makeshift. This is awful. I'm sure it worked. Electrically it'll work. But man, what a mess. What a mess. So, I'm going to sit here and undo all of this and then redo it properly. I'm going to check these resistors that were replaced just for fun. That one's the original one. These out of focus resistors here. These resistors are all brand new. I'm going to check their value anyway. And I'm going to see how bad this brown stuff is. If it's just, you know, damage on the outside, big deal. But I'm going to undo all of this and start from scratch because this is a mess. Alright, this is what the dog box is supposed to look like when there's no caps in here. I've tried to wipe off or clean up as much of this hot snot as I could. I don't want to do any more because I don't want to damage this original board. But I'm going to give it a little bit of a wipe down and just a brush just to get rid of any of this residue just sitting around. And then I'm going to populate it with the correct capacitors again. So, stay tuned, and the next time you see this, it will be populated with the right caps. Done. Just kidding. We got to put them in now. I just thought I'd put them in place, make sure, double check, triple check, quadruple check. I even looked at the schematic, and I even, just in case, even though I've done plenty of these, I just want to make sure I do this right, because if you don't, you will see sparks, you will blow things up. So just remember, this is the front of the amp where the knobs are, this is the back of the amp where the tubes are, and the output jack and all that stuff for the speaker. Okay, so everything that's facing the knobs is positive until you get to the very last cap up here, the big 100 microfarad. Originally they're 70 microfarad, 350 volt. I've gone for 100 microfarad, 450 volt. Now, these two caps are in series. What that means is, see, all of these are in parallel. So negative here, negative here, negative here, positive, positive, positive. This one, you can consider it one large capacitor. Now, Fender probably did this in the past because there wasn't a capacitor that was big enough to put just one cap in series. You would need, well, the original caps are 70 microfarad, 350 volt. So you would need, in series, it would halve the capacity and double the voltage if you put them in series. So you'd get 35 microfarad, 700 volt. Okay? They probably didn't exist back then, or they might have been too damn expensive, so it was cheaper to just use two. Even if they did exist, I don't know my history of capacitors to tell you for sure. So, however, what we've done here is we've put in our 100 microfarad caps, so together, instead of 35 microfarad, because 70 divided by 2 is 35, these are 100 microfarad divided by 2 gives you 50. 50 is close enough to 35. It's not that bad. And then, on top of that, we got 450 volt cap, 450 volt cap, so we double the voltage, we get 900 volts of power handling or voltage handling capacity there, whereas the originals are 350 volts, so that gives you 700 volts. So we've gone up in voltage and up only a little tiny bit in the capacitance. So these are in series, which means positive, negative, and then see this jumper wire here? This connects the negative of this cap to the positive of that cap, which makes it in series, comes around this side, and this is the negative side, basically, of this cap. So it goes this way, okay? The rest of these go this way. Ah, doesn't that look much nicer? So, this is much tidier than the garbage that was in here before. So we have our F&T complement of power filter caps here, just to run through. So this is basically your B+, this is your B+, essentially going to your other tubes here. So these all essentially run to your plates. Now, the resistors here are dropping resistors. There's one there, and one there. And essentially what they do is they're dropping the voltage down each time you go through the filtering process. These tend to be for the power tubes, so the 6L6s. Power tubes don't require a great deal of filtering, however there is some in place. So we have these two here, and what it's doing is after rectification, the DC voltage has a little bit of a ripple in it, and that's what these are filtering out. However, these filter caps here go to our preamp tubes, the 12AX7s and so on. Okay, 12AX7s preamp tubes are more sensitive. One way to eliminate sensitivity from them is to put these caps on top of them, these little shield caps, these shields. That stops any interference. Secondly, is they need more filtration than what is currently available from here. So this just smooths out the DC voltage even further to make it a nice, flat DC current pumping through to the 12AX7s in the preamp section. So 22 microfarad, 22 microfarad, 22 microfarad, 100 microfarad, 100 microfarad. That is as close to specs as you'll get with a modern day tube. And that's what we've done. As you can see, this is a lot tidier than the shambles that was in here before. Suffice to say, this basically means the job's done. The next step is I'm going to fire the amp up, put it onto an oscilloscope, check out the outputs from the different channels in here, check that the master volume is working, and finally, before I put things away, I'm going to do a physical inspection over the amp, because one of the things I have noticed is these tube clamps, well, if I can squeeze them like this, it means they're not in contact with the base of these 6L6s. Which basically means that these 6L6s are just dangling in the breeze, upside down in the chassis, and nothing is actually holding them in place. So I'm going to take each tube out, squeeze these overly tight, and then put the tubes back in, so the little teeth that are in here are going to grip onto the base of the tube, and I won't have any problems with the tubes trying to fall out, which can happen. Now, luckily, the tube sockets in here are quite tight, so that's not going to be a major issue. However, I still want to make sure that it is done correctly. Alrighty, folks, final piece of the video here. I've just got this hooked up to a signal generator now. I've got it hooked up to a 100 watt 4 ohm dummy load sitting over here on top of the tools. Got my scope connected, got the amp working now. Looking down at the oscilloscope, got a nice sine wave, nice and clean. So that's the preamp, the volume on the preamp coming in, and then I've got master volume as well. So that's 0, and that's about 5. And look, we can get the thing to go crazy. I can turn the gain down here, and there we go. So that's with it cranked. Okay, so we're getting a nice clean signal. Yeah, beautiful. Looks great. Not one bit of distortion, as you'd expect from an amp like this. So right now what I've done is I've actually got the oscilloscope connected to one of the outputs on the phase inverter. I just kind of went through and signal traced, making sure I'm getting a clean signal all the way through. And I am. So the next thing I'm going to do, because the amp's been switched on for about 20 minutes, it's well and truly warmed up now. I have been keeping an eye on the power tubes. We can see a little bit of a purple glow around the edges here. I was also looking at them closely to make sure that there was no red plating or anything like that. So what I'm going to do right now is I'm just going to measure the bias and put the amp back together and call the customer and tell them that it is ready to go. And that's basically it. So the amp is up and running, as you can see. Like I said, I put some volume through here, and we can see a nice, beautiful, clean signal coming through. So everything's great. So now what I'm going to do is I'm going to leave the amp turned on, rebias it, put it back in its cabinet, call the customer and tell them to come and get it. Job's done. Happy chappies. See you later.